We finally have the answer for how AMD could possibly compete with NVIDIA's research and development budget when it comes to machine learning applied to game, software, graphics, hardware, all of it. And that's to partner with Sony's PlayStation. Because PlayStation relies on AMD hardware, not NVIDIA hardware. And a lot of NVIDIA's research into machine learning, neural rendering, all of that is very proprietary. And that doesn't really work if you're trying to make the PS6 have a whole bunch of machine learning enhanced features and hardware and software and all of that. So what we got in the PS5 Pro technical seminar, which dropped today from Mark Cerny, is the announcement of Amethyst. This is combining AMD's red with PlayStation's blue to get that code name. And this is really, really interesting because, again, this is really acknowledging, if you watch this whole video, that AMD, well, how should I put this? That Sony, with their PlayStation, Mark Cerny here, really sees the future of big advancements in gaming graphics and hardware happening in ray tracing and machine learning. It's not that rasterized performance can't increase, but you just need to make bigger GPUs, faster memory. That's getting more expensive. It's getting harder to do. Whereas there's potentially, he says, quantum leaps in the near future for ray tracing, which is in its infancy, and especially machine learning as well. So that is definitely the future that PlayStation is looking at for gaming. And since a lot of games are developed on consoles, it looks like that, again, would then apply to gaming in general. And NVIDIA has a big head start in there for the PC space, right? But Sony gets their technology hardware-wise from AMD. So, again, it makes sense for this collaboration to take place. How about we actually listen to a bit of this directly from Mark Cerny so we can get what he specifically says? And how about I just maybe play the video? He explains things super well, although I listen to YouTube at 2x speed and he talks rather slow, so you get to experience YouTube the way I do. And if you're watching me at 2x speed, now he's at 4x speed. Whoa. Anyway, let's play this a little bit.
With Amethyst, we started on another long journey and are combining our expertise with two goals in mind. The first goal is a more ideal architecture for machine learning, something capable of generalized processing of neural networks, but particularly good at lightweight CNN.
Okay, right there, let's pause for a second. So the idea here is future hardware architectures for machine learning and AI. So they're definitely talking about a collaboration, not just on software, but on hardware architectures. Again, makes sense if they're getting their hardware from AMD for the next PlayStation. But they also say that this is for generalized machine learning and AI, but they want it to be particularly good at lightweight CNNs. CNNs are convolutional neural networks, and lightweight in the sense that if we're having this in mind, from PlayStation's perspective, this is for gaming hardware, right? Which means that things need to get computed extremely quickly to happen during the render pipeline. So that's what he means by the lightweight CNNs. This is the kind of thing you'd be doing with, for example, PSSR, PlayStation's, DLSS-style machine learning upscale. But then, AMD's FSR4, AI-based upscaling, right? That's kind of the idea. But as I talked about in my video yesterday, talking about NVIDIA research on neural rendering, things like neural texture compression, neural materials, there's a lot of room for CNNs to impact graphics rendering in the future. But again, consoles aren't working with NVIDIA. Well, I guess the Switch 2 is, that's a whole other thing. Anyways, Sony is not working with NVIDIA. So AMD and Sony teaming up for future hardware architectures that are particularly good at lightweight CNNs. I've got a lot more thoughts on that, but let's keep going.
Needed for game graphics, and something focused around achieving that holy grail of fully fused networks.
Now, he's talking about the holy grail of fully fused networks. Let me break that down a little bit. You guys could watch this whole thing. He does a great job explaining this earlier in the video. But he talks about the challenges of PSSR. Because when they tried to implement PSSR, the problem was it's not fully fused. And that actually has a performance impact. It means that it can be bottlenecked by accessing system memory during the process. So the idea here is that the way PSSR works is it doesn't take your entire image all at once and perform your upscale, it breaks it into tiles. And those tiles can be handled separately. And that's good. That relieves some of the bandwidth. But that information from each of those tiles needs to be stored and then put back together. But the problem is if you don't have enough memory on chip while that's happening, then you might still need to spill over into system memory, which can bottleneck the process. So staying on the chip as much as possible is extremely important. And I think I'll come back in a little bit and explain a little bit more about how Sony did that on the PS5 Pro hardware. But then we don't know if that's going to be exactly what AMD will be doing on future RDNA GPUs. But there is this collaboration here, right? So there's certainly at least learnings from what Sony was doing with the PS5 Pro, because obviously that was a collaboration with AMD. Anyway, so fully fused networks would mean that they're not having to, that all happens on the chip and accessing memory nearby it on the GPU itself. Anyway, let's keep going.
In going after this, we're combining the lessons AMD has learned from its multi-generation RDNA roadmap, and SIE has learned from the custom work in PS5 Pro.
Okay, so again, they're combining work from future RDNA roadmap that was, already something AMD was working on, but also stuff that Sony has learned from the custom work in the PS5. So again, we'll go back to the custom work on the PS5 Pro later on in this video, but it's not saying that what Amethyst will be doing is exactly what was done in the PS5 Pro, but there's learnings taken from it.
But ML use in games shouldn't and can't be restricted to graphics libraries. We're also working towards a democratization of machine learning, something accessible that allows direct work in AI and ML by game developers, both for...
Okay, that's interesting, because saying it's not just going to be graphics libraries, they want this to be democratized so that, CNN's machine learning hardware in general, just free it up to game developers to have a go at it, right? Democratize this, make it much more open, as opposed to having, extremely proprietary and closed uses of this. Makes sense, right? Anyway, let's keep going.
For graphics and for gameplay. Amethyst is not about proprietary technology for PlayStation. In fact, it's the exact opposite. Through this technology collaboration, we're looking to support broad work in machine learning across a variety of devices.
Okay, so notice that. The idea here is that this is not just for PlayStation. So Amethyst is not at all just AMD working with PlayStation for PlayStation 6 hardware. It's going to help that, it's going to be involved in that, but it is for learning machine learning across a variety of devices. Obviously, that would imply future AMD graphics on PC. So that's really, anyway, so that's definitely what this is talking about.
The other goal is to develop, in parallel, a set of high-quality CNNs for game graphics. Both SIE and...
Okay, so they want to develop in parallel a set of high-quality CNNs for game graphics. So they want this to be democratized so that game developers can develop their own uses of the machine learning hardware for gameplay and graphics, but they also want to develop a set of high-quality CNNs for game graphics developed by Sony and AMD so that those can be freely used. Again, so there's both work with them to democratize this as well as to develop libraries themselves that can then be easily used, again, for both PlayStation as well as future AMD PC GPUs.
AMD will independently have the ability to draw from this collection of network architectures and training strategies. And these components should be key in increasing the richness of game.
And notice they also mention it's also architectures and training libraries, so training as well.
Graphics, as well as enabling more extensive use of ray tracing and path tracing.
Enabling more extensive use of ray tracing and path tracing, and more on ray tracing improvements for future RDNA a little bit later in this video, because when he talks about the PS5 Pro's ray tracing improvements, that's coming from future RDNA. So we can learn about future RDNA ray tracing improvements from this discussion, which is really interesting.
Looking forward to keeping you posted throughout what we anticipate to be a multi-year collaboration.
And again, they anticipate this to be a multi-year collaboration. So again, this seems like a long-term strategy. And again, I think this is a great way for AMD to kind of foot the bill for all this R&D, as they can partner with Sony on it, not have to foot it, the whole bill themselves when compared to NVIDIA, who has the much higher market capitalization right now, right?
Let me get back to PS5 Pro for one final moment.
Okay, anyways, he gets back to the PS5 Pro and whatnot. So what I'd like to do next is talk a little bit more about what we can learn from his discussion of the PS5 Pro hardware. So one slide I want to pop back to is this one. So here he's talking about the fact that the base technology of the PS5 Pro, he's calling RDNA 2.x because it pulls in ray tracing technology from future RDNA. So we can absolutely learn about future RDNA ray tracing improvements by listening to what he says about the improvements to the PS5 Pro's ray tracing. But he also says the machine learning is custom RDNA, not future RDNA. So whatever he's talking about for the machine learning acceleration on the PS5 Pro is less likely to be just directly what AMD does with future RDNA. Does that make sense? Although again, when he discussed Project Amethyst, he did talk about their learnings in collaboration, with their work on the PS5 Pro. So clearly AMD could take some learnings from this, but I would say the ray tracing improvements, we could say this is definitely an improvement that's happening on future RDNA because it's from their AMD's roadmap. Whereas the machine learning improvements, we're less confident that these specific technologies will go to future RDNA. Does that make sense? So with that in mind, I think I'd want to jump to the ray tracing discussion first because that is the more direct application to PC. So we've got a few interesting slides to look at here. Here's one, and again, by the way, I really recommend you guys watch this whole video if you have 37 minutes or half of 37 minutes if you watch it at 2x speed like I do. Anyway, this is describing calculating ray intersections. And if you've ever heard BVH, bounding volume hierarchy, when you're hearing people talk about ray tracing, this is a visualization of that. So the idea when you cast a ray is that you need to figure out which triangle it intersects. However, if you, for each ray, calculate, if you're on a 4K image, you have like 8 million pixels, right? And you might have, okay, maybe less than that in terms of triangles, but the idea is that there are a lot of triangles in a scene. So you don't test the ray against every triangle. You want to quickly narrow down which triangles you need to test against. So the box here is a block, right? So, and this block, you can see quickly test that this ray has hit this block, but did not hit this block. So you can now quickly decide that you do not need to test if that ray intersected any of these triangles individually because it missed the entire block in which they were contained. Make sense? So now we can see that it did hit this block. Now, within this block, there's still a lot of triangles. So inside of this block, you see that there are 4 other blocks. Make sense? Okay. So now you test if it hit any of those 4 blocks rather than testing if it hit any of those individual pixels. Now we notice that it did hit this block. So we can now throw out those all the pixels in these blocks that it didn't hit. By pixel, I mean triangle, sorry. Anyway, now we need to test test inside of here. Now inside of here, you'll notice it is once again split into 4 blocks. So this is how we now narrow down the test for a ray, which triangles does it intersect. Does that make sense? You block it into chunks and check if it's hitting those individual chunks. So this is where a doubling of performance has taken place on the PS5 Pro by using those improvements in the RDNA, future RDNA architectures, so possibly RDNA 4. So the picture we were just looking at was BVH4, which is what currently happens on the PS5. There are boxes in groups of 4, whereas a BVH8 structure has boxes in groups of 8. So you can see that this would then double the efficiency of figuring out where this ray has intersected. Make sense? So ray intersection calculations could be doubled on future RDNA. That's good, but that's not all that ray tracing is doing. There's a lot more going on there. So the next thing he gets into is the difference is this issue, which is some ray calculations are very coherent and other ray calculations are very divergent. So what do we mean by that and why does it matter? And then how does future RDNA solve this issue, or at least improve this issue? Okay, well, if you're doing a calculation like sun shadows, the rays come in parallel. Or if you do a reflection off of a flat surface, if the surface is flat, the rays stay very parallel. So the calculations that you need to do based on those rays are often going to be the same thing applying to a lot of pixels, because the rays are doing much of the same thing. Whereas if you do a reflection on a curved surface or a bumpy surface, you can see that the rays may split off in very different directions, which then means that the calculations you have to do based on those rays could be very divergent, okay? Now, the importance here then is he has this diagram talking about how that happens. So when things are very coherent, you can do SIMD32, or I think you can also do 64. His diagram is here's for 32. This is single instructional multiple data. The idea is if you have a very coherent texture read, then that means that you're basically doing a single instruction on a whole bunch of stuff. Maybe this is pixels or something, right? Same thing for a lighting calculation. However, if we get those rays bouncing off in all sorts of different directions, this is where you get divergent processing. And he says that divergent processing could actually be dozens of times slower. And that's a major issue. So then we get this slide where he discusses that the PS5, which operates on older RDNA, has a stack calculation happening within the shader code. But what he says is on the PS5 Pro, which again is using future RDNA hardware, it's saying that it's done all in one, and I think he mentions that the stack has hardware to support it, right? So rather than being in code, it's in hardware. So this could have a massive improvement on performance, not on every ray tracing situation, but on highly divergent ray tracing situations. Now, so in other words, what he's then saying here is that performance on very coherent calculations like shadows and flat reflections has a good increase on the PS5 Pro. That's where that BVH structure has a big improvement, right? Maybe you're doubling your performance on ray intersections. Whereas as the divergence increases, then he's saying that it's a better increase on PS5 Pro. So maybe we're more than doubling the performance in these divergent scenarios. Now, what's a divergent scenario? Things like path tracing. You get these more complicated and divergent ray calculations, and that's going to be significantly improved. Now, he mentions in follow-up interviews and things like that it doesn't mean that the PS5 Pro itself is going to be great at path tracing, although he says he doesn't rule out that some game developers could be amazing and do some extremely optimized path tracing, and who knows? He doesn't want to rule that out. But I think he acknowledges that the PS5 Pro hardware itself it's asking a lot to do something like path tracing. But if these RDNA improvements happen on AMD RDNA GPUs, and those RDNA GPUs in the PC space, you could buy a GPU that is much more bigger, more powerful, and more expensive than the GPU in the PS5 Pro. Then potentially that's where you could get more competitive with the big, expensive NVIDIA GPUs, right? Anyway, so that's what I think we can learn about the ray tracing improvements for RDNA 4 and beyond because again, he specifically says the ray tracing improvements were future RDNA, just backported to an RDNA 2 base technology. The reasoning for that, I can't remember if I already mentioned it, is not because RDNA 3 was bad, it's because, or they couldn't have accessed RDNA 4 even. What he specifically says is if they had used anything besides RDNA 2, then a lot of the work to get games running on the PS5 Pro version would be much more complex for game developers, and you might need to have different shaders compiled for the PS5 Pro version. So the idea of these ray tracing improvements is that these are maybe even just a single shader that's different, or sometimes it's even invisible to the game engine. It just has improvements happen kind of automatically. So that didn't cause those issues. Okay, anyway, let's move on to the machine learning, which, to be clear, is custom RDNA, not future RDNA. So this is now less direct in how it's going to impact future RDNA GPUs, but that doesn't mean we can't learn anything about how they do it. So he specifically talks about the main convolutional neural net, CNN, that they were focused on for the PS5 Pro was upscaling. They talk about there's a variety of methods that you could consider using in order to do this type of thing. But that the big issue, let me turn off the closed captioning here. The big issue is, okay, first of all, do you choose to go with an NPU or an enhanced GPU? And they chose to go with an enhanced GPU. Now, we know that AMD on the PC side of things, especially for like, chips designed for laptops, are having NPUs because, Microsoft wants that for, Copilot Plus, but it's not necessarily gaming applications, right? Sony is very focused on gaming applications for gaming consoles. So they chose to go with the enhanced GPU because the type of thing you're asking a CNN to do on a gaming console is things like upscaling, which if you look at the rendering of a game frame, happens in the middle. You do maybe your 1080p render, and then you do your machine learning based upscale, and then you output maybe a 4K render. Now, because that happens within the rendering of a game frame, this needs to happen extremely quickly. That's what we saw at the beginning of the video referred to as lightweight CNNs, which are applicable to gaming. But also, it doesn't make sense to bounce all the way over to an NPU to do that, right? It makes sense to stay on the GPU. So you enhance the GPU's ability to perform the types of calculations necessary for this type of upscaling. Now, he talks about the fact that they wanted to get 300 TOPS of 8-bit using bytes as input on the PS5 Pro specifically. But again, this is specific to the PS5 Pro, not necessarily to future RDNA. He then talks about there being a bit of an issue on all of this because, okay, if you have 300 TOPS, you can't actually access that efficiently if you're bottlenecked by bandwidth. So when you need to access memory, we have a bit of a problem. As I think they've got some diagrams that go a little bit better for this. So the idea here is that ideally, you read from system memory, and they're saying like you might need 128 megabytes if you're doing a 4K image. And then ideally you take that, you perform your upscaling, and then you write that back to system memory. The problem is that system memory is slow. So if at any point you're not performing the entire upscale all at once within this process, if you have to bounce back to system memory at any point during your upscale, then you have a problem. Because then your memory speed is going to massively bottleneck this process. He says that it can go all the way down to just 9 TOPS, which is 3% efficiency because you're bandwidth bound if you're doing it this way. So the idea then is to, the holy grail, as he said at the end of the video, is to get a fully fused network. Where's the image here? So ideally, you get a fully fused network. The fully fused network does not have to go back to system memory in the performance of this. From going from your input to your output, you stay within the GPU. Okay, so they need that's the goal. Now he admits later on that PSSR did not achieve this goal on the PS5 Pro's hardware. But again, the PS5 Pro's hardware is not future RDNA, it's custom RDNA. So hopefully the learnings from this can help future RDNA, right? Maybe RDNA 4, maybe it's further out, who knows, actually be able to do something better than PSSR. And I think that, in my opinion, this is, I've looked at a lot of the coverage from places like Digital Foundry, looking at the quality of PSSR upscaling. And it's had some image quality issues. And also when you look at its performance numbers, and it's hard to measure it directly, it's maybe not as performant as you would like. Which means that it would be really nice if FSR4, if that's what they call their AI-based upscale on the PC side of things, it'd be nice if it's better than PSSR. So it would be nice if, I think it would help to have a fully fused network, that kind of idea. And so to help them, but anyway, we can keep moving on with this discussion. So What they talk about here is the idea is that you break the overall image into tiles so that you can do more of this in parallel. So rather than having to do the entire frame all at once, because the entire frame needs 128 megabytes, where are you going to find that quickly if you're staying on the GPU? So you break this up into individual tiles, although he then gets into there being a limit to how small you can make the tiles, so there's a limit to how parallelized you can make that process. Then they get into, okay, so where do you find extremely quick memory on the GPU? Because this needs to be, he says, much faster than something like L2 cache. He's like, L2 cache, not anywhere near fast enough. We're talking in the needs of hundreds of teraflops per second in effective speed, but that can be cumulative based on the parallelization. So he went back to these workgroup processors. The PS5 Pro GPU has 30 of them, and then mentions that, okay, if you think creatively, that the workgroup processors have vector registers. And on a vector registers per workgroup processor, you have 4 sets. Each set has 128 kilobytes at 1.67 terabytes per second. Now you might be like, that's not hundreds of terabytes per second, and it's also not very much memory. But the idea is you're splitting into those tiles, which can then be spread across your workgroup processors to your vector registers, right? That's the idea. So by splitting that up, the combined 30 workgroup processors has 15 megabytes of RAM at a combined 200 terabytes per second of bandwidth. So that's interesting, right? However, that also means that they didn't meet the needs of a fully fused network for PSSR, unfortunately. Now, let's see, what other info do we get off of this? Okay, so basically then what they did is they created 44 new shader instructions that go into a takeover mode, one tile being computed per workgroup processor. Anyway, so I do need to be clear about all of this, that is how the PS5 Pro's custom RDNA machine learning acceleration works. Again, I need to emphasize that that's custom. It's not necessarily what future RDNA is going to do on PC. Also, that means that it's I think, unlikely that PSSR is the same thing as an AI-based FSR. But I do think that it makes sense, and he did reference this later in the video, that the learnings that happened based on all of this are shared for Amethyst, which does provide a future for RDNA 4. Anyway, this is extremely interesting. I am really excited to see what comes of this. And I think this is the answer to, okay, so is AMD going to try to compete more directly with NVIDIA's focus on ray tracing performance, machine learning applying to games, accelerating gaming through, there are still advancements in overall rasterized performance brute force, but the big, quantum leaps, as we hear in this video, coming more from the advancements in ray tracing and the machine learning applications. And so how does AMD compete with the smaller budget? That's what we kind of learned here. Partnering with Sony, where PlayStation benefits from it directly, so let's partner up. That's where we get Project Amethyst, and we learn a little bit about what that might be. Now, I tried to find out if there was any additional interviews with Mark Cerny with additional details. I'll pull up maybe an example of that here. Where this is WCCF Tech. So to be clear, this presentation that we're looking at, it was just made publicly available, but it seems clear that this actually happened back more during the initial announcement of the PS5 Pro, but that this was under embargo and only specific media outlets were privy to this information. And to be clear, I was not. So this is all new information to me. However, a bunch of media outlets have now published their private follow-up interviews with Mark Cerny about all of this. And so most of these interviews focus on the PS5 Pro specifically. However, some outlets did ask a bit more about Project Amethyst. One of the outlets that did so is WCCF Tech. So if we follow up on their Q&A and just ignore everything about PS5 Pro, we could get a little bit more out of Mark Cerny regarding Project Amethyst. So WCCF Tech asks, the big surprise of today's presentation was the Amethyst machine learning project with AMD. What are the first steps of that collaboration going to look like? Mark Cerny's answer, well, we've already started talking. Pretty much when PlayStation 5 Pro was wrapping up, we began discussions and development of those various aspects of Amethyst. To get more specific, I think we were getting pretty good momentum by the end of 2023. But as you know, it takes a phenomenally long amount of time to go from discussions and concepting to actually having a piece of hardware out in the marketplace. Okay, now I've got some interesting thoughts on this. So good momentum by the end of 2023. So thinking more on how this applies to AMD in the PC space, future RDNA, and specifically their machine learning like FSR4 with AI upscaling, think back to the video I did a while ago where Tom's Hardware interviewed Jack Huynh, the president or vice president, something like that, of AMD's gaming division, so definitely somebody who would be in the know here, talking about an AI-based FSR that he at the time, and this was in September of 2024, had mentioned that it had been in development for something like 9 to 12 months. That was September of 2024 where that interview took place. Notice this statement here about Project Amethyst getting good momentum by the end of 2023. Well, the September of 2023 might qualify, and then a year later, that's 12 months later, there you've got that interview with Jack Huynh referencing 9 to 12 months. Okay, so to me that makes sense as a direct connection to that previous information we had about AI-based FSR4. Let's go ahead and continue reading here. So another question we had from WCCF Tech to Mark Cerny is, one thing you touched on during the presentation was the democratization and standard libraries between SIE and AMD, which would be developed in parallel. Can you talk about how that partnership is going to be built out? Okay, Mark Cerny's response. Certainly. Well, for hardware first, really this is not about PlayStation proprietary hardware. We're looking to co-develop performant new AI architectures that can be used freely in any space that anybody chooses to use them, whether that is PC, console, or cloud. So this is big. So this is talking about, let's be real here. So NVIDIA is making a absolutely unheard of, just massive amount of money off of data center stuff for AI, right? And a huge part of that is that NVIDIA not only has hardware for this, but they also have software libraries, training, all sorts of stuff. And AMD is not quite there as a direct competitor with, as fully featured. Now, to be clear, in the cloud data center stuff, I'm less of an expert than I am in the gaming side of things, right? But my impression of my understanding of this is that AMD, they're developing some big hardware for this. They're trying to compete. They have software to compete, but it might not be quite as fully developed, as fully a competitor to what NVIDIA has on offer there. So Sony's looking to co-develop performant new AI architectures that can be used freely in any space that anybody chooses to use them, PC, console, or cloud. So it sounds like this is looking at, are we taking on NVIDIA's like CUDA and direct and their machine learning programs for cloud and like all sorts of stuff. This seems very big research partnership here. He also says for the software, if I look at it today, we have games that run on a TV, and there's a certain set of developers that make them. And AMD for PC has games that run on PC monitors that have a somewhat overlapping set of developers that make games for them. So he's basically acknowledging that while the console gaming space and the PC gaming space are different, they're massively overlapped, right? Well, he says somewhat overlapping, but they're very overlapped. There are different needs and different relationships there, so there are differences between console gaming and PC gaming. So really what we're looking to do is to co-develop those network architectures and those training strategies that can then be freely used in both contexts. So again, being very clear that the learnings here are designed to go both ways, PC and PlayStation. This is not PlayStation exclusive. They're really looking for a partnership and more free use in this space. Anyway, I think the last thing that's worth touching on here for the PC crowd is the question. Another key word from the presentation was discovering the holy grail of graphics through fully fused neural networks. What does that look like in your mind? Mark Cerny's reply is ultimately what you would see is really high quality libraries based on CNNs, that's convolutional neural networks, I talked about that a bit earlier in the video, for game graphics. To me, that's a bit of a prerequisite. You need to have hardware that is capable of doing that. So I think he might mean that that has a bit of a prerequisite. Do you see what I'm saying? So you need to have hardware that is capable of doing that. And it seems to be from his presentation that even trying to just do PSSR, so an upscaler kind of like DLSS, on the custom machine learning hardware within the PS5 Pro GPU really wasn't able to be a fully fused network. So you need to have hardware that's capable of doing that as a prerequisite. And so that's, I think, a huge part of what they're trying to develop with AMD. Now, again, for graphics, what they want is really high quality libraries based on CNNs for game graphics. So again, we're getting into this like neural rendering, right? So like I said, look at my video yesterday where I talked at some of NVIDIA's research on neural textures, neural materials. I think the potential future for what you could do with this is, massively interesting to consider and potentially revolutionary, but you need the hardware that can do that. But specifically, from Sony's perspective, you need AMD hardware that can do that because they're not working with NVIDIA as a hardware partner. And then you also need to develop those training and those libraries and all of that. And they want this to be much more open. So I think the idea here is to move towards what NVIDIA is basically doing in the PC space, but very proprietary and running on NVIDIA hardware specifically. Whereas Sony wants this to be much more open and specifically running on AMD hardware, although ideally it could also run on NVIDIA hardware. And maybe we get away from a bit of the, proprietary nature of a lot of what NVIDIA is doing. Because I'm going to be honest, I'm very interested in game graphics and pushing the boundaries and GPUs and technology and all of that. That's why I have this channel. So I'm very interested in what NVIDIA is doing with all of this. But I don't like how proprietary it is. So I'm really excited to see how successful this ends up being. Obviously, a big point where this really needs to be effective is the next PlayStation, PS6, right? What happens in the PC space in the meantime will be interesting. How much of this do we see with RDNA 4, or is it not quite ready yet, right? They got some good momentum by the end of 2023, but, it takes a phenomenally long amount of time to go from discussions and concepting to actually having a piece of hardware out in the marketplace. So is that RDNA 4 in 2024? Or are we talking AMD GPUs coming out along the lines of when a PS6 comes out or something like that, right? Anyway, I think that this video went way longer than I expected. So how about we wrap it up here? I will link the sources in the video description. Let me know what you think about all of this in the comment section. I hope all of you have an excellent day.